Good afternoon. My name is Євгенія Ткач, and we are going to talk about the structure of phytodiversity of a semi-natural fitocenosis or plant variety. We understand the processes in this field, so that's why politicians and scientists have to focus their attention on three main things: environment, economy, and improving quality of life of a rural population. The concept created at the beginning of the 1990s has its principles, criteria, and it provides for reaching the main goals of balancing rural and urban area. Over 72% of Ukraine are agricultural land. That's why the agricultural landscape and fitocenosis is absolutely necessary. There are a lot of species that are under threat of going extinct, and these animals have their habitat in farmland. We can call farmlands semi-natural plant communities. So far, it's not clearly identified how exactly these fitocenosis or plant communities are shaped. We have to work hard to preserve and restore diversity in these semi-natural plant communities. There are valuable farmlands and also forests. And additionally, there are also some water bodies. All of these surfaces represent value for the economy and the nature of our country and for the world. It's important to maintain and preserve all the species that live in these territories. There is lack of sufficient. There is not enough sufficient data to fulfill our tasks. Nonetheless, we still have some important principles that enable us to fulfill our goals. Territories are definitely facilitating the existence of local species, and it's typical for any climate zones. There are other principles. For example, species can be unique to specific territories. It's important that we support them. Next principle, prospective development of land so that all the species can be preserved and resources can be utilized in the optimal way. Considering all the principles and values, it's important that we keep in mind both biological and landscape values. We have to have plans for preserving fitocenosis these semi-natural plant communities. To that end, there should be specific like roadmaps and plans. There is some low intensity farming activities that contribute to this purpose. In picture 7, you can see structural elements of different plants which are grown in a typical low intensity farming model. it's most frequently used in farms, which are working in the field of horticulture, or they combine horticulture and animal farming with low intensity. Such farms have a high diversity, semi-natural plant communities, or mosaic of semi-natural and natural communities. Such farms can be of all European or global significance. We have to focus on identification of mosaic of semi-natural and natural plant communities. Threshold values for semi-natural plant communities have to be described as detailed as possible. These bottom and top thresholds are important to be described for each particular region. This range would enable us to define what species we are dealing with in this territory, and to choose the best species for farming. And we, on national level, we have to do some local testing before we make our choices. There has to be a piloting stage on local level with the consideration of the key criteria for identifying semi-natural plant communities. It's necessary to do such piloting, implement such pilots in all regions of the country, in different regions of the country. We can say that mostly semi-natural plant communities are predominantly residing or living in farming land. There are key stages of implementing this study, consisting of a description of main criteria to assess semi-natural plant communities, the criteria to assess the animal and plant species living there. Fitocenosis of landscapes are influenced by humans, and they contain a lot of other facets or factors. Based on
this prerequisite
components of agricultural systems, we can talk about specific anthropogenic and natural factors. There are different anthropogenic factors influencing the plant communities. They define their structure, functions, and existence in general. These factors include the following: historical factors, land management types, herbicide, pesticides being used, regulation of soil moisture, biodiversity sometimes or often is shaped despite the purpose of people. Diversity of natural and anthropogenic factors influences the results of the study and monitoring which should follow the study. In any ecosystem, there is specific characteristics of how intensively the plants grow and how capable they are of having offspring, how actively they can shape soil structure. Considering applied factors, we have to also list the following qualities. In territorial, administrative territorial units, the end goal of our study is to ground the optimum activity of human activities and to prevent environmental damage to the land, animals, and plants. To avoid unnecessary interventions. The key areas of the study is morphological, ecological, and other activities of plant communities. Key principles of monitoring. There are some controlling activities to identify some deep transformations and changes. We have to be conducting continuous activities to monitor each indicator. The validity of study results has to be considering spatial and temporal fluctuations of all the indicators. And we have to monitor all kinds of objects situated in the studied territory. We have to be systematic in our studies, and we have to consider all interrelated factors of the system we're looking at. The systematicity has to consider taxonomy, topology, and flora sections of the object. And it means we have to look at molecular composition of the plants and soil we are studying. There are the following activities we have to conduct. We have to organize data collection. It has to be continuous. And we have to look at obligatory indicators of each member of plant community. We have to anticipate or predict further development and changes for short-term and long-term horizons. We have to develop consultations for emergency situations, and we have to also develop plans of overcoming the potential challenges. The key criteria of environmental assessment for plant community include climatop, hydrotop, trophotop, and anthropotolerance. We have to also look at thermal or temperature mode, the contrast mode, and so on. There are different types of soils in each region, and we have to consider this as well. Precipitation should also be taken into consideration. When we look at the phytodiversity, we have to define and determine key qualities of species in this habitat, their adaptivity, urbanization of each species, and how well they are adapted to anthropogenically disrupted environment. This is how we were doing our study based on all the principles and criteria I just described. You can look at the map and see that it's the central territory of Ukraine, Vinnytsia, Kirovogradska, Kirovograd, Odessa, Cherkasy regions of Ukraine. So these territories represent steppe, forest, and grassland of Ukrainian territory.
The area of the research is in Halachina, Slobozhansky, and Southern Bug eco corridors. The key areas here are varied ravines and controlled and guarded territories of the state value. The research areas are located in these areas specifically. The climate in these areas is continental, mildly continental, and more susceptible, more pleasant for agricultural activities. Multi-year values of air temperature from 17 meteorological areas, stations in Ukraine from the NATO database indicate that this territory is the researched area over the last 30 years is characterized with a raise of average annual temperature by 1.7 degrees. Based on the degree of plant communities, we've conducted following research. So diversity of soil. Based on the initial research, the different regions. In varied regions, we've identified the following ecosystems with classification of plant communities. And we've identified that these plant communities are semi-natural ones. Among these areas are ecosystems of natural and semi-natural areas, meadows, forests, steppes, swamp systems resulting from melioration activities, enclaves of natural and semi-natural wood blocks and brushes that were maintained in the cultivated land, water dividing forests and brushes, and biotopes resulted from agricultural activities of a human being. Those are perennial gardens, very old ones, local wood blocks, and ravine systems. In the areas studied, we've identified the following areas that were classified as semi-natural plant communities. You can see this on slide 26. When we identify the intensity of activities, next on slide 27, we can see examples of those territories that were studied by us. Those are enclaves of ecosystems of semi-natural and natural low-level vegetation enclaves, natural areas, natural areas, and biotopes resulting from agricultural activity. When identifying the intensity of agricultural activities, we used assessment. We conducted assessment of ecological state of agricultural landscapes. One of the components here is the assessment of ecological stability and anthropological load on the piece of land. The basic quality marks are identifying ecological balance, resilience, and grade of transformation under agricultural transformations is the coefficient of anthropogenic load and coefficient of ecological resilience. The coefficient of anthropogenic load is characterizing the human activities on the environment, including the land resources. These coefficients allow us to identify in complex how rational, how feasible the land usage is of the territory. Based on these, on the coefficient of ecological stability, we identify the ecological state of the researched areas. The coefficient of researched stability resulted, the values of the coefficient was 0.3 in Odessa region, 2.42 in Kyiv region. While the anthropogenic load coefficient varied from 0.35 to 0.69 correspondingly. So the territory of the studied region is ecologically unstable, which results resulting from increased levels of anthropogenic load. The lands of agricultural lands, also identified by a coefficient of tilling, it varies from 50.77 in Kyiv region to 71% in Kirovohrad region. It's one of the key coefficients is and resulting from our research, identify that the agricultural activities resulted in significant change and transformation in landscapes. A key role in hazardous situations in landscape related to anthropogenic factors, including agricultural and land cultivation. The key role here is tilling, and with the percentage varying from 48% to 72%. The coefficient of tilling in destabilizing condition, resulting in destabilization of ecological landscape and results in higher anthropological transformation. The qualitative state that we observe in the researched areas, its research, we need to say that the agricultural impact is very negative. Over the last several years, there is a trend and constant trend in quality deterioration of grounds, of soils, and that not only results in reduction of resource potential of the whole region, but in separate areas, which in turn affects the quality of other natural resources, including water resources, forests, and also flora and fauna. When assessing the agricultural territories to obtain a high quality and safe products, plant products, and maintaining semi-natural plant communities is tied to availability of unsafe objects, also the balance of natural conditions and the technologies that are used in agricultural activities in producing agricultural crops. The area researched is favorable for agricultural with a high anthropogenic impact. The soil conditions and climatic conditions correspond to the demands for growing significant agricultural areas. We've identified the impact of agricultural technologies on the quality and safety of agricultural crops by conducting ecological certification with key criteria of agricultural assessment. The impact of technologies on the ecological state of plant communities impacted by the criteria of soil productivity, phytosanitary state, and other key features of the crops and harvests. And our research showed that the studied technologies need to be significantly improved. Specifically, the fertilization system has to take into account the soil fertility and has to foresee the norms of better norms of utilization of fertilization to improve fertility to the decent level. Also, this has to take into account land cultivation and also has to be aimed at improvement on the phytosanitary state of the crops. This would result in improvement this would result in the necessary yield improvement and also reduce the negative impact on the environment, reduce the spread of sanitary plants in semi-natural plant communities, and also reduce the negative impact on the state of the plant communities itself. Presence of semi-natural plants. For that, we conducted taxonomy and typology research of the plants, of the vegetation. And the results are as follows. We've identified the spectrum of lead families of phytobiotics and plant communities. The results are, there are 1,167 plants in 61 types and 81 families. The floristic spectrum analysis showed us that there are 23 families that are have more species, more species than the environment. That's why a small number of families is leading in terms of natural diversity. There are several families that are they don't have too many species, and this is a feature of Arctic flora. Once proper planning and management of cultivated lands is employed, this would allow to improve the situation. This information will serve as a basis for the role of plant communities in cultivated lands in assessment to form local lanes, parts of national ecosystem in Ukraine, and that would allow us to maintain biodiversity in the cultivated lands. In the modern science, an eco-flora complex approach is used. This allows us to study and research all the diversity and dynamics of semi-natural plant communities. This would allow us to also provide a typological explanation for their complexity. The eco-topology structure taken into account variety parameters of floristic complexes. This, when we studied similarities and diversities in flora in varied territories, we've identified that there are typical areas of maximum similarity between plant communities are in Odessa, Kirovohrad, and Vinnytsia regions. The lowest relation between the steppe areas in Kyiv, Odessa, and Kirovohrad regions. Likely, this is due to formation of species diversity by plant communities under impact of climatic change. Since the Kyiv area of research is in the northern parts of the steppe, while Kirovohrad and Vinnytsia included the southern part of the steppe, that's why the variety of species is so different. We also need to identify the high coefficient of likeness between varied plant communities. This high similarity is related to similarity in technologies of plant growth, and also availability in also lack of technology maintenance, lack of proper usage of mechanical assets, and hence the plants in all plant communities is highly diverse between different areas, which is mostly related to physical location and soil and climatic conditions, and also the anthropogenic load. By biomorphology structure in the researched areas, we have mostly perennial plants. Most of them are hemocroptophytes and phenophytes, and the lowest one are geophytes. There are a lot of families that are widely spread in semi-natural plant community and are of varied level of how guarded they are being. We've also identified then semi-natural plant families are tensed, critic, and catastrophic states. This is related to their significant anthropogenic impact. Mostly, this is related to woodblocks, furrows, and only ravines, valleys, and lakes have a relatively normal state. The steppe areas are impacted the least. You can see there are one year plants, and you can see there's a spectrum of plant communities. In there is impacted the least. By water regime, most types are mesoxerophytes, xerophytes, and mesophytes. Also, varied areas are related to varied systems. That's why it's mostly covered with mesophytes and mesoxerophytes. While in the woodblock areas, it's mostly mesophytes and mesoxerophytes. We've also identified mesoxerophyte plants in areas of lakes and rivers. We identified water and swampy areas inhabited by those kinds of plants. By the light regime, most species are related to xeophytes and helioxeophytes. The plants that feel much better in shady areas. We need also to point out that the dominating factors here are meadowy species, woodland species, and also steppe species. About 14% of the researched species are cenotropods. The results of distribution of the species between the different types of groups, we have the following distribution in terms of relief relation and other factors relation. It's known that one of the factors of a biological threat, factors of threat are inventive organisms. Due to wide mobility and lack of natural enemies, invade and secure areas of natural ecosystems and cultivated lands by pushing out indigenous species that are mostly rare or endangered. Among the areas, among the organisms like that are widely spread the organisms that are harmful for agriculture. This requires usage of herbicides, insecticides, and other specific agrotechnical methods, which leads to increase in energetic and technical costs. We've identified that adventive flora in the researched plants. Among the research plants, there are 177 higher plants. By the state of ecological threat, among the advent plants, there are potential and balanced without an identified succession perspective. The most threatening advent and substant with substant perspective plants, there is about 5% of those. This is mostly in landscapes that suffer the highest anthropogenic influence. Leading families in adventive plants include up to 30 species. That is about 60% of the total number of advents. After analyzing the flora, the plant community of cultivated land by the time of introduction, we mostly have archaeophytes, those species that were introduced to Ukraine before 462. By the naturalization intensity, amorphites, and also by distribution type, the most dominating ones are erhasiophytes, and by the type of there's a difference between the naturalization. There is a relation between naturalization and the state of introduction. Most types are archaeophytes and cyanophytes, while splitting this ratio half and half. By the distribution of adventive species by the regional criteria, we've produced 26 arealic groups in habitation group. Euro-Asian, North American, and Mediterranean are the most numerous ones. They together comprise about 78%. The regions of where those adventive types come from, we've identified 35 regions of those 35 regions that those species come from, and the most part is related to the southern areas of Europe and Asia, which identifies a high level of hordization. There's also a part of the North American that comes from North American regions, relating to the fact that the climatic conditions in our region is very similar to the ones in North America. By the hemorrhagic coefficients, we've conducted a comparative analysis of the flora and fauna, and this showed us that about 83% of the species are polyhemerobes. The researched areas that include adventive species includes varied areas with high level of anthropogenic transformation, meaning that the most part are hemerophilic species. This means that in plant communities of cultivated lands include a high partition of adventive species. And this results sometimes up to 47% of which indicates high transformation of the researched areas. This specific group of plants allows us to identify the key peculiarities of this group of plants and identify how possible for them it is to adapt to the right conditions. These researches has to be conducted all the time, consistently, and this would allow us to control adventive species and then control the expansion, the spread of this group of plants. When assessing anthropogenic changes based on numerical factors, we identify that the symmetrization index, mostly those plant communities are of the type with high anthropologic transformation, but anthropization, anthropophytization indexes and kenophytization index, their high values identify that there's a high the apophytization is higher than the adventization. This means that those species are naturalized in the transformed plant communities and can compete with local species. We've also studied and assessed plant diversity, phytodiversity, with hemorrhagic, hemerophilic, and hemerophilic and hemerophobic of those species. We've identified a general trend of increased hemerophilic from semi-natural fitocenozes, and all the way to all the way to ravines, furrows, and wood blocks. The value of anaerobics shows us how valuable these areas is, because there are rare and endangered species of plants are located in here. This also impacts the value, well, by the index of anaerobic. The higher the index is, the more it's characteristic for plant communities with high impact of human activities. Ravines, by this index, has the lowest lowest index. It means that those areas are under the least impact by humans, and they maintain the natural plants to the best extent. And any sort of changes or diversions from that is mostly an exception rather than a rule. By the coefficient of destruction, based on the scale of the anthropogenic impact on semi-natural plant communities, we've identified that phytodiversity relates to fourth and fifth classes of destruction, with higher than average levels of destruction and high level of destruction. The category of development of these phytotopes comes from anthropogenic transformations, and this results from human activities. Out of 1,167 species, we've identified 122 species that are rare or endangered, that are also in the Red Book of Ukraine, Red List, European Red List, Convention on Wild Flora and Fauna Protection, and Convention on Foreign Trade of Wild Flora and Fauna. These are endangered species. We've identified 3 species spread in varied types of semi-natural plant communities, but are less spread in Kyiv, Vinnytsia, Odessa, Cherkasy, and Kirovarad regions. Based on our population analysis, we analyzed models, the modelic regical species, including that are of international and national flora-seasonal status, introduced into the European Red List, Ukrainian Red List, and Ukrainian Red Book. On the example of Pulsatilla bohemica, we'll show how the population was changed. The Pulsatilla bohemica is a polycarpic hemicryptophyte and mesoxerophyte. It's the family of Ranunculacea. It's a Central European polymorphic species on the southern border of the inhabitation area. We've identified this. This appears in edges of woodblocks and also grassy hills. The number of population is mostly right-hand spectrum, which identifies, which signifies the, based on the research, we've identified that this species is mostly realized in the wood and steppe area with a mild anthropogenic load. We've identified that by the classification of delta omega, the population of Pulsatilla bohemica in the plant communities of the central wood and steppe, there was a transfer from, in the Kyiv region, from young to transient, in Vinnytsky region from young to old, and in Cherkasy region from young to transient. This dynamics shows that there's a huge impact of anthropogenic factors, and that affects the potential of existence of these species in wood blocks, edge wood blocks, and in the central wood and steppe of Ukraine. Our next research is the problem of forming of the central eco network of Ukraine in the context of spread of the green network of Ukraine. There are boundaries between the naturally protected areas of Ukraine in both floral and species aspects. To assess the efficiency of the key areas, we've calculated their relationship, their accessibility, their centrality, and their agrofragmentation. The relation degree is the degree of how those are connected, is the number of eco corridors related to a certain area. The higher this value is, the more alternative routes of genetic material exchange between diversity centers there is, and the higher resilience has this territory from anthropogenic factors. Accessibility and centrality are features of highest lowest Vitim index and highest read index and highest read index of relative accessibility. The Маслівська, Богодеснянська, Чернобинська areas of the Halицko-Slobozhansky Southern Bug territories have the highest indexes. When forming migration routes between the eco corridors, we've identified that there's an availability, but a lack of migration routes for movement.
Probably this is related to heterogeneity of the objects of our studied objects. We have established several cycles despite the fact that how these species are spread in the territory. They have weak relationship. The graph shows that the network of eco corridors related with each other are not branched enough. Halицko-Slobozhansk and Southern Bug regions cover the most key territories that are representative for forest and steppe territories. Based on our study and assessment of agricultural landscapes and considering the diversity and principles we mentioned at the beginning, forming of semi-natural plant communities enable us to correctly analyze and assess these territories and identify them as structural elements of agricultural land and landscape. Thank you very much. That's it from me.